Hello and welcome back. This is section 4.2 from chemistry, and as you remember we talked about the Bronsted-Lowry acids and bases. So again, this is going to be a little bit of a refresher and a chance for you to earn some points on Play Posit. And it is required that you do this. So in the Bronsted-Lowry acids, we were talking about what happens to that water molecule. And we learned that that water molecule can actually accept a hydrogen ion. And when it does, it becomes a compound that now is H3O and is known as hydronium. And hydronium is an indicator of whether you're dealing with an acid or a base within a solution and the chemical equation. So if this will let me advance, which it's not, there we go. So hydronium ions are also known as oxygen ions. The significance that we saw in this is that that hydrogen ion is actually going, or the proton, remember we were calling it a proton, is going to actually bind with the water, and it's going to make this hydronium. And we're transferring it. That transfer of the hydrogens is part of what is known as the Bronsted-Lowry principle. According to the Bronsted-Lowry theory, an acid is going to donate a proton. So if we have hydrochloric acid here, it's going to be donating the hydrogen that it has to form a hydronium and a chloride, and a base is going to accept that proton, that H+. So in this particular case, the water is going to be the base in the reaction, because this hydronium is going to be the base in the reaction because it accepted the proton, and the acid, of course, is going to be the one that donates it. Okay, so this hydrochloric acid will dissociate to produce the hydronium and chloride when it dissolves in water, and the proton is not released but transferred to another substance. So this is being transferred to this water, which is another substance. So in the Bronsted-Lowry acid, it either releases or donates a hydrogen in a solution. So in this particular example that we have, here is our ammonia and ammonium, and it has 3 hydrogens in it. One of those hydrogens is going to be transferred, I should say one of the water molecule hydrogens is going to be transferred, and we're going to get an NH4 in this particular case, and we're going to get OH. So let's go back for 1 minute. An acid donates a proton and a base accepts it. So the water in this case is going to serve as our acid. It's going to be donating it to the NH4, and the NH4 is going to wind up being our base because it accepts it. Okay, so exactly what we just said on the screen before. This water is going to act as an acid because it released the hydrogen, the proton, and it joined with the NH3 to make NH4, and the NH4 then acts as our base. So with Bronsted-Lowry bases, we don't have to worry about the pH. We don't have to worry that it is greater than 7. We don't have to worry if it changes the litmus paper to any color. All we have to do is to be able to look at our equation and determine which is our acid, which is going to be donating the proton, and which is our base, what's going to accept it. So one of the things we just saw is that water was very unique. In our one example, it acted as a base, and in another example, it acted as an acid. And for that reason, we can call water amphoteric which means both. It means that it can be an acid or a base. Okay, so then we started to talk about conjugate acids and conjugate bases, and I see some spelling errors. Okay, now we're going to take a look at another type of acid-base property, and we're going to call it a conjugate acid-base pair. And a conjugate acid is the type of acid that is going to receive a hydrogen ion, and a conjugate base is a type of base that donates the hydrogen ion or the proton. So when we take a look at acetic acid, notice that acetic acid has hydrogen in it. And when it reacts with the water, it's going to lose this hydrogen, and that hydrogen is actually going to be transferred. It's going to be donated to the water, and it's going to become known as that hydronium ion. All right? So now looking at this, we have to decide which one is going to be that conjugate acid and which one is going to be the conjugate base. So a conjugate acid is the type of acid that receives the hydrogen ion. So let's take a look. Which one of these received the hydrogen ion? Well, it's the hydronium. The water did. So since the water is receiving it, this water is going to be considered the conjugate acid. Now the conjugate base is going to be the one that donates it, and this one's going to be the conjugate base. Let's see if we're right. So here we go. Since this releases it, we're going to release that. That acetate becomes the conjugate base, and because this is the hydronium is picking it up, the hydronium is going to become the conjugate acid with this. All right, just exactly what we said. That water molecule, it's going to accept it, it's going to become hydronium, and that's going to become that conjugate acid because it's accepting it. So, oops, went a little bit too far, and this is a little bit shifted here. When we look at this again in the same perspective, the acid and the conjugate base are going to make up a base pair. So the original acid and then the conjugate base that was made, and notice that it's just the one without that, that's going to be known as the conjugate pair for that one. The conjugate base pair for this is the water, because the water starts off as a base and then it goes to an acid, and that's a conjugate base pair as well. All right, and they match, they kind of match. So let's take a look. We've done this one in class, so you're familiar with it. We've got sulfuric acid, we've got ammonia, and we've got hydrogen sulfate and sulfate, and an ammonia ion. So here, what we're seeing happen is that the sulfuric acid is going to be losing one of the hydrogens, and it's going to be becoming hydrogen sulfate. So I'm going to pause for just a minute with a question and ask, what is this sulfuric acid and what is this hydrogen sulfate? Think about it. Hold on, I'll be back. How'd you do? Did you say that the sulfuric acid is the acid that donates, and the hydrogen sulfite, the ammonia ion is the one that's going to accept it? So this is going to become the acid. But as far as our conjugate pair, sulfuric acid and hydrogen sulfate are our conjugate pair in that case. So ammonia then starts off as a base, but because it accepts it, it's then an acid. So the ammonia and the ammonium ion are the conjugate base pair there. Okay? All right, we're going to stop there, and we'll make the play posit out of this.